Hi, and welcome back to another Physics 2 problem. This is from the fluids unit, and this is actually a problem about buoyancy. So this is a really cool problem. They give us, let's take a look at it. Without reading it exactly word for word, here's the layout of the problem. They have a container. They put two liquids in them. Okay. Now they give us the names of the liquids, but the names of the liquids aren't important. We're not expected to know the densities of them or anything. We just know that there's a liquid floating on top of another liquid. So this is in this case, mineral oil, and then ethylene glycol, but doesn't really matter. Two liquids with a distinct boundary between them. And then we put an object that's floating exactly halfway between them. I'm just going to simplify this object. I'm going to draw it as a sphere. Doesn't matter what the shape is, but it's exactly halfway between them. All right. And then they just ask us, what's the free body diagram? So they give us a bunch of, I'm going to label these actually. Let's use a little bit of color. I'll call this, instead of worrying about the names, liquid 1 and liquid 2. Okay. And now they give us a bunch of free body diagrams in the multiple choice to choose from. So this thing's floating. The first thing that you need to know, if this is floating, it's at equilibrium. Okay? Equilibrium means that our net force is 0, which means no matter what forces are acting, they all cancel each other out. Okay. So the next thing that we know any object on Earth has is a downward force, Fg, the weight. Okay? And that's going to be the mass of this game piece times gravity. They don't give it to us in the problem. Doesn't matter. That's the weight. Now, we know that when things are submerged in liquids, a buoyant force is applied to them. So the first thing you have to make sure, one place that people get mixed up is they say this liquid's on top, it must be putting a downward force on this object. It's not. This object is displacing this liquid, which means that is creating a upward buoyant force. I'm going to just draw it as a line. I'm not going to put my arrow on it yet, but we know it's straight up. Okay, that's our buoyant force from liquid 1. I guess I could even label it, but we're going to worry about the magnitudes in a second. So I'll call this buoyant force 1, FB1. And then liquid 2, also applying a buoyant force, FB, for liquid 2. Now the question is, and they give us in the multiple choice a couple different options of different lengths of these. So now that we've eliminated the fact that we know there's no downward force from liquid 1, which one of these is going to be greater? And based on our diagram that they're giving us, we know that liquid 2 is more dense. And our buoyant forces here, buoyant forces are always equal to the weight of the displaced fluid. So if this is more dense, and it looks like we're displacing exactly the same amount of liquid, that means our buoyant force, if you remember, buoyant force is rho, density of the liquid. I guess I could put rho liquid, times the volume, times G. The volumes are the same for liquid 1 and 2. Gravity, of course, is the same. So, since liquid 2 is more dense, liquid 2's density is a bigger number, which means it's creating a greater buoyant force. Okay? And I'm not drawing these exactly to scale. Maybe I'll try my best. I could have counted these. Actually, that looks pretty good, right? Because we know that the green arrow and the blue arrow should be, when we add them together, equal in magnitude, right? If I slid this up here, it would be up here. And the sum of them is about exactly the same length as that weight of the object, okay? So there you go. That's how you solve that problem. Hope it helps. Take care.